Hi, my name is Sérgio Silva. I'm a PhD student at UTAD University. Today I'm presenting to you my paper entitled Augmented Intelligent Distributed Sensing System Model for Precision Agriculture. Over the past years, augmented intelligence inspired by natural evolution evolved to the implementation of algorithm models that combine artificial intelligence techniques supported by human interactions and sensor data integration, providing new ways to look to the existing data and transform it into valuable outputs for areas that before were difficult to introduce innovation and technology. Agriculture is one of the most ancient activities of man, but its evolution has not kept up with human needs. In order to increase production and ensure its sustainability, it is necessary to move towards precision agriculture. This work uses the advances in sensing and communication technologies. This advance has brought down the deployment cost using the emerging wireless technologies with low power needs and low data rate capabilities, which perfectly suits precision agriculture. Today's agenda will encompasses the work motivation and general and specific objectives. Then I will explain the implementation of the distributed sensing system model. After I will make a brief note to the gateway and implemented software, and then I will take you guys down to a tour of the data collection model that we are currently implementing and give you an idea of our future work. I will finish by explaining the several entities that are collaborating and their roles in the project. The main motivation, besides the need to ensure a good wine, is that water supply is limited, and today, 2/3 of the world's population currently live in areas that experience water scarcity for at least 1 month a year. And this problem affects not only some third world underdeveloped countries but affects us all. In Portugal, some areas already suffer from this water scarcity. Water is a precious resource that must be taken care of every day. But the water scarcity is also felt by plants, especially by vineyards. Grapevines during July and August need around 120 liters per week. Young vines have restricted root systems in both extent and density for several years. We need to ensure the water that we supply is the necessary in order to have a great wine. In the present work, we aim to study a new methodology for the cooperative control of the sensors in order to achieve crop control and water, ambient and soils monitoring using a wireless network of sensors with low cost and maintenance. The DSS model aims to be a network of sensors which will increase efficiency in farm water consumption, through data analysis and automation which can reduce water costs up to 5%. For that we have established a series of general and specific objectives that help us focus on the results that we want to obtain with the DSS model analyses and implementation. Some of the more important objectives, besides the general objectives, that focus on improving the crop production and wine quality, are the development of the augmented intelligent water stress analyses from the mounted sensor network, together with ambient and historical data in order to find outliers that help us understand the vineyard as a living entity. To achieve data collection and implement the above-ground network, we decided to use commercially available devices together with new sensor implementations allowing us to try LoRa and other radio protocols. The main gateway, that receives, stores and forwards all collected data to the cloud, is presented in this slide. The gateway is a fully energy autonomous system and can be accessed by 3GE or 4GE or using narrowband IoT. On the software side we have implemented a Node.js application, with event-driven asynchronous JavaScript. The internal database, besides storing data, allows us to have a backup every time the system cannot connect to the network, either because it has insufficient power to establish and maintain the connection or just because there is a network cover failure. The gateway also allows local monthly display of information concerning humidity, temperature, wind and rain, in the form of tables and graphic representation of the data with parameter tendency. But the platform is only a local gateway. The stored data is sent using JSON to the cloud, where an endpoint expects to receive the data via a HTTP POST request, for further augmented intelligent analyses. Using collected data, we are introducing historical weather location correlated data for further augmented analyses and anomaly detection. The graphic shows relative humidity from 2006 until December 2020. This data is now stored in our cloud and can be used as a parameter for our model. The model presented makes use of several data sources to make the wine quality prediction model. It is grouped using two labels, long-term data and dynamic data. Regarding the long-term data, it includes several flavors. First, it uses information about the vinery, namely, the number of vines, the grape varieties. Regarding the dynamic data, it uses macro-environmental information, namely, temperature, precipitation, evapotranspiration, air humidity, air temperature, exposure to light. Finally, the dynamic data encompasses fine data collected locally using sensors. Sensors exploit soil and environmental parameters, more precisely, soil humidity, soil temperature, air humidity, air temperature, evapotranspiration, wind speed and direction, solar radiation. In order to address the problem, we have included two key steps in the process of building the model. The first one looks at long-term information, while the second component uses dynamic data to extract outlier-specific information that will feed the model creation. The prediction model is constructed based on these figures, provides a system overview. The long-term data is by far much more stable. For instance, the number of the vine does not vary at a fast pace. Likewise, the variety of vines remains without radical changes over time. However, it is known that even with the same apparent characteristics, the quality of the wine varies over the years. This means that the quality of the wine must be also influenced by other parameters, in particular parameters that vary more dynamically over time. Work consists in exploring the real-time, in-field testing of the system and use collected data to feed the model and address wine quality and water scarcity. By deploying the prediction wine quality model. This work has the following collaborating institutions: Universidade Trás-os Montes e Alto Douro and Instec as research institutes. Quinta do Castro as the wine grape farm where the system is being deployed. Altis Labs as the communication provider. Globaltronic as a sensor and gateway provider and developer. Thank you for watching. I will be available for some questions during Q&A session.